everyone, and thank you for participating today. We've got a number of people that are still attendees that registered that are still coming online here, but I wanted to open up our discussion. First of all, happy Earth Day, or Day After Earth Day. It's actually by coincidence we held this talk on this important day. The AIA Monterey Bay Committee on the Environment is pleased to bring you the final lecture on Earth's 4 elements, titled Earth, Saving Our Soils. The previous 3 were presented in 2020. Earth, Saving Our Soils will discuss green design strategies that mitigate, reduce, and capture CO2. These design strategies can help promote physical and emotional well-being through attractive and effective site design, as well as benefit the environment. This webinar qualifies for 1.5 HSUs and will be reported by our AIAMB staff. This lecture is being recorded and will be placed on the Monterey Bay website under the COTE tab, and we'll let you know when that's been uploaded. At 1 p.m., we will open the floor to questions. You may enter a question in the Q&A box or raise your hand to ask a live question. We want this to be interactive, so please feel free to get on and ask your question live. In coming up with a specific subject to explore with regards to Earth, our committee had come up with the idea of soil and how it pertains to siting a building. It was also suggested that we bring up the themes discussed in a captivating documentary called Kiss the Ground on Netflix, which speaks to carbon and soil. So we hope many of you were able to preview this, and I'll put a link to its website in the chat shortly. This lecture will also bridge our 2020-2021 program, which will focus on writing green specifications. In the coming months, we'll have some exciting webinars, including a general talk on how to approach green specs, Division 1 Construction Waste Management, +1 on Division 5 Wood, Cross-Laminated Timber, and Division 7 on Insulation. Today's webinar will feature local ecologist and landscape designer Paul Kephart of Rana The Cohabitat, a design firm located in Carmel, and John Kasunich of Haro Kasunich Engineers. Paul Kephart is the principal ecologist and designer at Rana. Paul is sought after as a pioneer and innovator of living architectural systems, a thought leader in ecological design, and a dedicated horticulturalist. Paul has consulted on many groundbreaking and iconic projects, including large-scale living roofs at the Croton Water Treatment Plant, the Vancouver Convention Center, the Trans Bay Terminal, and the California Academy of Sciences. Paul Kasunich is a principal geotechnical and coastal engineer and a founder of Haro Kasunich and Associates, a professional consulting firm dedicated to providing geotechnical and coastal engineering services to private and public clients throughout the Central Coast since 1984. I would like to thank John and Paul for participating in this webinar with support from Lara Burton of Rana and Shemaine Jones, our executive director. With this introduction, I'll now turn the presentation over to John and Paul. There you go.
Do you want us to go over these learning objectives, or do you want to introduce those?
Yeah, we can just pause on this. So these are the learning objectives that were submitted to AIA. So we'll just spend like a couple seconds on this, and we can always come back to it. And I can also put it in the chat.
Yeah, sure. Thank you for the introduction, and thanks AIA for inviting John and I to speak today about this important topic, about the soil, about the earth. And I've known John for probably 30 years. Our careers have intertwined on certain projects, but we hope to make this like a conversation. He through the eyes of an engineer, a civil engineer, and and an expert on soils, and me through the eyes of an ecologist and an ecological designer. I first want to kick this off by talking about the importance, and without soil, we wouldn't have life on the planet. It provides nutrient cycling for plants and that important hydrology, biodiversity, and habitat, the water and its relationship to the earth. And it also supplies the structural support for our living buildings and systems. And one of its most valuable functions is that of carbon sequestration, and that most of our carbon that we utilize on the planet comes from the soil. Our issue now is we have fugitive carbon up in the air, and we try to do everything in our design efforts to keep that carbon in the soil. That microbiome is rich and diverse, millions and millions of microorganisms, bacteria, archaea, viruses, and fungi. And this is what determines our plant health and human health and well-being. There are current studies relating to the use of pesticides that kill off this microbiome and how it affects the human immune system. So this microbiome is really key and important to human health. Some of these threats that are quite common that we see every day and we're a part of as architects and designers and developers on all scales, and now on a global scale. Probably the one that we see most and are affected by is the erosion over excavation, soil tillage, especially living here near the Salinas Valley or the Central Valley, where air quality is impacted, carbon loss, acidification is happening all over the state. These contaminants, waterlogging, compaction, and salinization, these are all the kinds of threats that we hope to not just mitigate, but to create a better environment. So if our goals and our values are not just to limit or minimize threats, they're to create a world and a situation where these threats are overcome. Another major threat is this idea of soil tillage. In 2000, this is from the film Woody Harrelson had narrated, and it was the day in which tillage, where all the farmers on the planet were most active in their soil tillage activities, and we had peak carbon monoxide and abundance in the atmosphere. And this is just from bearing the soil. About 70% greater amounts of carbon that day. John and I both can speak to this because we're often involved in regulatory and protection requirements in our work. I'm particularly encouraged not just by regulation, but by voluntary participation with the Living Building Challenge and LEED sustainable sites, where we're limiting soil disturbance and grading, and we're setting aside soil and habitat, not just to mitigate, but to improve and to restore for the betterment of the building envelope and for the betterment of the people that occupy that.
Mm-hmm. I could chime in here a little bit, Paul, just to state that Santa Clara County and Santa Cruz County are becoming very strong advocates of minimizing grading and land disturbance in setting up your development concept. And we're first online there relative to developing the recommendations for that. And we began and now are adjusting to it in a pretty positive mode.
We want to talk about the planning process and how one might start to think about soils. And John and I had this conversation with Libby the other day, and that oftentimes as a biologist or an engineer, we're called in sometimes a little too late. And oftentimes we'll get a set of plans with a site, the house is already sited. It might have been based on access, some criteria around views, proximity to vegetation and existing trees. But then we get into the analysis work and we find that maybe that house wasn't placed on the best soils, or maybe it was placed in a place that would harbor birds or rare butterflies or plants. So I'm going to give some examples today of how to get on top of the planning process and begin to understand the importance of soils and the ecology. And this is really for the long-term values and of the natural environment and how we can protect those. This is a sample project that we used soil maps and looked at the USDA soil maps for erosibility. And we used GIS layers to understand where the existing and proposed home sites could be on this 4,600 acre ranch. And erosion was ranked, and we developed this map to look at these sites, and then looked at soil permeability as well as watershed. So this is where not only the soils have more infiltration, but the soils accept more water and can store more water. And when we look at these results, you look at another criteria, the riparian buffer, the soil erodibility, the landscape classification, that's the vegetation, and the topography model, slope and aspect being key to soil disturbing activities. These green dots represent those areas that are most suitable for development. So before we even looked and went out in the field and looked at views and vegetation and access, this was one of the first analysis tools that we utilized just to look at soil and how we can modify our plans relative to soil. Vegetation is key, and really the vegetation patterns, they follow that of the soil. And so based on that vegetation we ranked the development suitability, and we're able to come up with key locations that made sense from a planning exercise on where to develop. Another project that speaks to adaptability, and this is not necessarily targeting future development, but we use this in a way in which we could undevelop. And I have a friend that says there's so little time and so much to undo. And when we consider the factor around climate change and sea level rise, this was a park called India Basin in an underserved community. And the first thought I had was how to restore the environment. So we developed an adaptive landscape in order to save the soils from the erosion of the sea. And it involved taking out the armored seawalls and laying back the soil into what could become in 25 and 50 years marshland and grassland, and eventually brackish marshland. So as the sea level, it's a way of yielding. There are other ways to do this where you could go out and build a seawall, which is yet another structural intervention. But this was a way of adapting or thinking about how we could adapt the soils and the sites for future threats around climate change.
You know, Paul, as coastal engineers, we're taking it serious because the California Coastal Commission doesn't allow anything else. And we've been around long enough to realize that's a positive reality. We're starting to do pretty large developments, at least in the planning stage, elevated piers above what's coming, really like Polynesians have lived for a long time in the low-lying islands. And these are big, expensive projects. So it takes some muscle to do what we're talking about, but we're doing it, at least planning wise.
Yeah, that's encouraging. And, you know, the regulatory process in the state moves slow. It affects all of our work and planning. But we do have design criteria on how to think about how to integrate site and structure and how to minimize the kind of grading, starting with the programming and really understanding how you program the site based on the soils and based on how you can preserve them. And limiting grading, John, you mentioned this, is that, you know, that we're really looking at how we can minimize with piers, posts, elevated grade beams, contouring. I like the idea of key lines and contouring, so we're not cutting off knobs of mountains and filling into lowlands, but rather we're integrating the site and the structure with the grades. John, I think this is yours.
Yeah, this is a job we just completed probably 2 weeks ago in Pacifica, where there was an extreme amount of instability. This is actually, if people can remember, about 10 years ago when those homes were falling off the cliff at Pacifica. They were on TV about every night or hanging over. The city took over, moved the homes, worked things out with the owners. You can see that there's a strip there and it runs up coast, down coast, that now belongs to the city. And then they have their road, the Esplanade. We stabilized the largest slide, built the seawall at the base, but part of the project required public access, those are 200-foot near vertical cliffs in Pacifica. And this is the result of developing public access down to a bottom seawall with some stairs. And we did it with all biodegradable mulches, and also the pathway is a pretty new DG material with a stabilizer made of ground up husk, all organic, that fills in the voids, keeps the soil particles together, yet absorbs water during rain and flow and doesn't allow disengagement. And this is a pretty steep grade, so we're going to see how well this works, but it is a good application to trying to keep, you know, water in the ground and return growth to the slope and allow public usage.
When I think about site and structure integration and minimize grading, I want to refer to Mickey Munich's work and how Mickey did a number of projects that were low impact. And I remember when I worked with him on this project, I was concerned about a coastal prairie and the soils there. And Mickey smiled with a twinkle in his eye and said, not to worry, we'll just lift it up and place it on the rooftop. And so this is another strategy, and one in which we've done in large scales everywhere in the world now, in which we can simulate or replicate the function of soils, the bulk density of soils, as well as the slow down runoff and enhance the residence time of water on the site. So when the water does leave the roof, it has a slower velocity. It's oftentimes cooler. Contaminants are scrubbed out of the air, and there's a number of benefits to these kinds of interventions. Here's the Pavey house in the prairie, in which it was folded right into the grades and the ridge lines and the key lines of the property. So really an elegant project, so well integrated with the land and the spirit of the place, protects the biodiversity of this and the health of the soil. And of course, the Post Ranch Inn, which many of you know of, and how instead of just carving off the mountain, Mickey placed the structures on piers and posts and delicately inserted these bungalows into the landscape with the prairies on top. Now on to some larger projects, and I often think about the scale of these places that most of the opportunity to either protect or mitigate for or enhance soils in the urban environment that started in Switzerland in the 90s, in which case they recognized the impact that the cities had on the environment, particularly riparian corridors, palustrine ecologies, and they developed site mitigation requirements that the developers were required to replicate or simulate the infiltration, so for targeting a zero runoff. And the message here is that healthy soils are really related to water and hydrology. And if we can work with a healthy hydrology, then we can protect the soils in the surrounding areas. So often our work now requires us to create new soils, and in this case, it's on top of a parking structure. But we look at these building systems that we can integrate food, biodiversity, energy, and water, and it's all interconnected. And a recent project that we just finished that is characteristic of the scale that's of developments that are happening here in Hangzhou, China, near some very important wetland ecologies. We did this project with Renzo Piano to help create permeable space within a 10-acre super block of development. And the idea here is, the big idea was around preserving the agricultural production. The soils there now are so contaminated from sulfur and lead that their foodstuffs, 26% of the soils in China are in a toxic mode. So we imported organic soils, we augmented them, and now we're producing tea on 10 acres of roofs. This tea is prized and it's a new cachet. The financial model also worked out in that the farmers that tend and care for the tea are getting a high return on the production. But there are other benefits in terms of modulating the energy use of the structure. And again, it's about water and slowing that water down so that as it enters the surrounding waterscape, it doesn't have erosive characteristics on the soil. And we're seeing this on a number of large-scale projects that we're working on throughout the world to integrate food as well as soils on structure. So some of these, John and I will talk about these soil preservation strategies. And John, why don't you take this section on and we'll kind of tag team on it, since we showed some of these in your earlier slides.
Yeah, you know what's interesting is in the hydrologic cycle, water, the amount of water on Earth remains the same. It just recirculates or stores itself in different ways. The soil, the topsoil has 0.005% of the total water, a very small amount, and it's so vital. Geotech engineers, soil engineers tend to like to compact everything we're dealing with because it's fail-safe for supportive structures. So we take natural soils that have 15 on the low end to 30% porosity or void space, and we bring it down to about 10 to give you the 90% or even less. if we're at 95. And it's actually just it's become a habit of how to support many things besides buildings all around, including playgrounds to keep them tight so you can put in all, I mean, just that's something that probably we need to think of, even if it's costing a little more in the end, but that would reduce a lot of void loss on larger projects. So,
this is where John and I get into a spirited discussion every time, and that the soils engineers want 95% compaction, and then they ask the plant folks, the landscape architects and the ecologists and the horticulturists, now go establish climax vegetation within 3 to 5 years and 80% cover within 90 days. And the soil has lost its capacity to nutrient cycle as well as its capacity to hold water.
That's right. You know, the hydro seeding industry, at least locally, has really evolved in better products, all biodegradable tackifiers, things that would allow us to not worry as much at the resultant erosion that could occur. And with the biodegradable rolled blankets for erosion control that are really easier to apply now, and they merge with this this mulch to not only contain a lot of ground cover, but it is definitely supporting quicker germination and a better percentage of growth in a shorter period of time. And that particular industry has really, I think, got on to this soil preservation strategies from a business point of view. And I think it's a positive step forward. We're learning, but using it quite a bit more on a regular basis, smaller projects that wouldn't even think about it because it's easier to apply.
Mm-hmm. Now we're going to shift into some more LID or low impact development strategies. And really this again relates to water. And if we manage the water, we can protect the soil. So we've used things like flow through planters that have a weir in them, and the water can back up and be captured and harvested. Bioswales, rain gardens, detention and retention ponds. But what we're trying to do is reduce or prevent adverse runoff impacts through that site planning, and then also both structural and non-structural techniques. So from an ecological standpoint, I like to mimic or simulate nature. And so I would go with more of the non-structural techniques whenever I can, and create swales, rain gardens, depressions, healthy planted soils. Here we see both. We have a engineered solution with a flow through planter and a bioswale side by side. These structural strategies are often in conjunction with hardscape or parking spaces or foundation work or water capture facilities. And then what happens is that runoff that hits the impervious surfaces of the parking is captured and filtered through that flow through planter, and then has a chance to get all the sediments out and slow the water down, cool the water, pre-filter it, and then enter a bioswale like this, fully planted, supports a number of insects and birds, and then into the watershed and its surrounding.
Yeah, you know, both on small and large projects now, all of the soil firms are asking the architect or the civil engineer going in, should we run just some short percolation tests while we're drilling holes out there.
Yeah.
It's become common for us to ask because we're often in the past asked to, well, what does it percolate? And we're in the last quarter of the project rather than in the first quarter of the project. And we've done all our field work, et cetera. So we're really, I think that's becoming just a standard way. We want to know the strength of the soil physically, but we want to know its permeability and ability to, hold water as a regular basis now.
Well,
Small and large projects, single family homes, all the way up to large parking lots, and et cetera.
That leads us into this idea of pre-planning and what are the things we can do prior with getting a more integrated design process. And that means getting all the folks at the table early on, especially during the siting discussion. Get the soils engineers, landscape architect, the ecologist there at the table to start to analyze and study the sites. And we did this on a large project in San Antonio where that shaded area is an area where you cannot infiltrate. Those are karst, cave-like soils, structures with rare and endangered spiders that live there. And the strategy here was to nearly double the program. And then also, given all the existing parking, there's you begin to realize there's really a limited amount of space for the new development to occur. So we began to analyze this in terms of there's a mandatory detention area. We needed to meet the programmatic requirements and the siting of these structures and their scale, and it also informed their morphology. So there was so much we learned in terms of just analyzing the idea around soil and infiltration and the regulatory environment for this mandatory detention. And what it led us to do is to kind of analyze where we could place those structures and then how we would control the runoff for a more of a zero runoff strategy. And we developed these traditional stormwater BMPs, detention ponds. We looked at living roofs and cisterns and bioswales, pervious pavements, and then these kind of linear flow-through type swales and street side applications. And all of them were ranked and analyzed in terms of their efficacy by gallon of water treated. And what was so fascinating about this exercise is that the bank wanted to know the cost of each one of these and how they may be used together or separately, and what was the optimized solution. So I developed a program based on these variables, and that it was a database that would adjust those values around water treatment and water capture relative to each one. And what we determined is that really from a cost basis, this pervious paving, the cistern, the bioswales, and the detention basins, even with long-term management, really won the day. Whereas in this case, the living roof and the linear flow-through type swales weren't really as optimizing the solution for the mandatory detention. So this is just an example of some BMPs that can be used to capture that water, that protect the surrounding soils. But what was positive about the experience is that we began to understand where to program, what scale, building morphology, and siting issues early on in the process. And so if the civil engineers, the landscape architects, and planning happens together with the architects, we save so much time and money. I've been on many projects where this hasn't occurred. Buildings are placed, program is determined, and it's too late to turn back, and we've spent time and money, and then we have to go through another redesign phase. I think, John, you were talking about, let's not wait till the fourth quarter of the project.
Yeah, I agree with that. This is all not only positive, it's becoming required, and it's a necessary ingredient that should be up front. And I say that because we're the soil engineers and we're out there able to do whatever people need. We just need to know to incorporate that in scope of work at the beginning, because more often than not now we're coming in the end and it's just not efficient.
And I do want to talk a little bit about permaculture. And when we think about it, it's often in terms of gardens and farms. And, you think about this art and science of integration. And when I think living systems and optimizing each one of the elements of those and how we apply it to the built environment. And that's how I want to differentiate the discussion is, and really it's about stacking functions. How do we optimize each one of our design moves, our design intentions to relate to, affect, and optimize all of the elements of the built environment? That's waste, energy, food, water, soil, habitat, health, and well-being. And what are those kinds of measures that we could take into consideration? And as a sample project, the Vancouver Convention Center, by capturing all the laboratory water, we took all that water out of the sanitary sewage and diverted all that water at a less cost and saved it from entering the bay. By placing this 5-hectare living roof, we enhanced the habitat, the green space, the views, real estate value. But there were some surprises along the way in that the treated water, when it was then, I always say, the last time I was there were 11,000 people irrigating this roof just by washing their hands. And this is the largest single span exhibition hall in North America. So you can imagine the energy loads. And so another one of those functions that were stacked by this measure, reducing runoff, habitat, views, real estate values, was the energy consumption and the carbon footprint. And what we found is that it carved the peaks and the valleys off the energy demands and just flattened it right off. And that was something that early on, I mean, this is a fairly old project, but it was very advanced in thinking around these integrated systems where wastewater was used to irrigate the roof, in which the thermal performance of the building was enhanced. So much so that the roof and the systems that it's based upon were paid for in about 4 years. So we also got an ROI on this. And I think that's the take-home message that, these sustainable measures are great, but when they can pay for themselves, it really starts to make sense. So the idea is that we can take those principles of permaculture, those ideas of optimizing and stacking the functions by these symbolic measures, can really enhance the building and at all scales. We're doing this now on a residential scales, new home in Malibu, where we're taking wastewater and then out of a koi pond, for example. And that koi pond water is brought up from a reservoir from the stormwater. And that koi pond has nutrients, waste, that are irrigating the orchard. And that orchard provides food for the owner. And so these integrated systems is where the future lies in our built environment. And it all goes back to really the fundamentals of how do we protect the earth and protect our soils. Here in San Francisco, we just took on this new park, and that area in the middle there was a reservoir. It's been filled, and now it's stormwater storage and water, non-potable water storage for the park. But some of those measures that we talked about here, minimizing grading, this is a very steep site. It's erosive soils, historic sand dunes. It's all going to be restored. Just as a temporary measure, we covered the soils with plastic. I don't like to do this, but it was a event rain, and the downside of this is the water velocity can be channeled, and you really have to be careful with these. But we also not only minimized the grading with the elevated walkway, but protected the existing trees. So the design really worked around the existing trees and the grades. Now we're just getting to the planting of this project now. This was a $26 million project that was privately funded by the neighborhood. And how I'm just so thrilled to be a part of this. When can you ever get to build a new park in the middle of a city? It's going to provide so much in terms of habitat, and it's going to be a safe place for kids to play. And but these are some of those measures that we took early on to protect the soil and protect the grades. In summary, I thank you today for Libby, especially for inviting us. But when we do these kinds of measures and implement the kinds of best management practices that John and I shared, we can enhance the beauty, increase diversity and productivity, really protect and enhance that carbon cycling, increase hydraulic functions, integrate design process. And really what it's about for all of us is to make the world a better place. And notice I use the terms increase. Often in our work, we just try to mitigate or get back to zero or less than significant impact. And what we're after is to really make it better, more good and more betterment for not only us, but all the creatures that also inhabit the planet with us. So thank you. Thanks, John. It was good to be with you. And one of these days we'll get another project to work on together.
Yeah, you're welcome, Paul.
Great, thank you. That was fabulous. We're doing well. We're a little ahead of schedule, which is fine. I'd like to open up the floor to questions and answers. So Justin's going to take that on. And if you'd like to ask a question live, we encourage that, hear your voice. And so raise your hand if you'd like to ask a live question. And Justin, I believe we have some in the Q&A. Do you want to go ahead and ask those?
I'll go ahead. Some people have typed some questions in the Q&A box, so I'll go ahead and pass those on. Polly was asking if you could describe the difference between soil compression and soil compaction, if there is a difference between those two, and how would you differentiate between the two?
Yeah, I stipulate in our work that the soil is compressed and not compacted, because when you think about compaction, you're almost doing that mechanically. You can still do it, but if you're going to establish seeds, if you were to walk across the site and you don't make an impression, it's too overly compacted and you won't get your seeds to germinate. And that's when these blankets and other measures, hydromulch, the reason why that seed is suspended in tackifier is that it can't get in contact with the soil. It's too hard and slick, and that's part of the reason why hydromulch sometimes doesn't work. The soil is too tight. But if it's just the surface of it is compressed to where if you walked across it and your boot heel sunk in about a half an inch or so, it means there's space, air, and nutrients available and space for seedlings to germinate. So that's really what I mean about the difference between compression and compaction.
Is there a scientific measurement? Like John, maybe this is a good question for you. If there's, and also is there a different kind of foundation for compressed soil?
Yeah, you can look at it the way Paul described, and that's right. Traditional compaction is mechanically breaking up the soil environment, putting it back in place to take grain upon grain and nestle it together and remove the void, increase density. We measure that with pounds per square foot compared to what is the densest we can get it. That's the compaction curve. What we can do and have done is where we have to disturb soil and cause and allow it to still support different structures, we can, number one, reduce the compaction requirement, go from 90 to 80, 85, reduce the bearing capacity, make sure we're not getting bad or high differential settlement, and live with wider bearing surfaces. That's one thing. And we also can easily use much lighter compaction equipment by specification. I mean, a very small light roller, not filled with water, compresses rather than sheep's foot ties it up and puts it together very tightly. We've been educated to do the latter, but if we design for the former, and that is just push it down, we can sustain long-term bearing. Remember, we're geotech physical soil engineering scientists, and we're trying to integrate with the biological requirements of life science. And it's tricky, but it can be done. You just have to get away from old habits and try new, and do it a little bit slowly.
What's the best way to protect the soil?
Yeah.
Is there a
Best way is with roots and plants.
I'm wondering if there's something that can be actually written into a specification, like do not compact the soil any higher than blah, blah, and design a foundation to go with that. Or
there are specs, Polly, for that, and that you can still have a sub base that's compacted for the slope requirement or stability requirement. And then you can add on to that spec for a topsoil added or a mulch or a compost or another soil that's retained for the plants and get those started. And those specs are out there.
If I can just jump in as it pertains to compaction, a question about how have the environmental services in our local jurisdictions, have they embraced these techniques?
Well, you know, from our point of view, they'll embrace them if we condone them, honestly. And, you know, to get specific with Polly's question, we're doing a lot of permeable pavements and DG materials that normally we would just compact tight. It's quick, it's easy, and you put anything on it, it's going to work. We're now being cautious about that so that the structure, it's not a building foundation, Polly, but it's a slab, it's a driving surface, it's a playground, it's a pedestrian walkway. Not only does it support its purpose, but it actually infiltrates, holds water and infiltrates it into the deeper zone of the more native soil that we're trying to preserve. And the answer is if we recommend it, they will allow it. We take the heat if it doesn't work. And honestly, some of it doesn't. And we try to figure that out quickly if that's happening. We've also learned how to do it right so that we're not having mistakes, if you want to call them that we had in the past. So we're more aggressive and confident in the present. And it's also become a requirement. I think I've been doing permeable pavements, for 15 years now. Certainly 10 is a requirement. You don't even get an option. And the requirement is not just jurisdictional. We must do post and pre and post drainage has to be the same. So we have to contain and retain materials. So the architect is looking for this solution right off the bat. There is no other choice. And the civil engineer and geotech try to work with him positively.
That's great, guys. Marilyn Crenshaw had a question, and she was asking, is there a measurement matrix available to measure carbon that has been sequestered that we can use in our projects now?
If you, that's a really, really good question. And we're, in terms of building performance, we're starting to do that for rooftops and landscapes. And we take baseline carbon sequestration values from representative analogs, vegetation types, soil depths. And then we look at those criteria or those measurements around height of vegetation, roots, soil depth, cover, and permeability. And we've done a couple of exercises around this in the built environment. I'm pretty sure that if you, I think there's a landscape design firm, Kevin Congers, the founder, CMG, and on their website, I think one of their principals developed a tool around carbon for the landscape and for buildings. So you might look there. We haven't formalized it, but we've certainly done it before, and I think it's a really an interesting future application of how we can make sites better. We do know that wetland ecology sequesters 35% more carbon than dryland landscapes. So the more water, more moisture, the more carbon. That's the simple answer. I don't have a tool for you, but you could try CMG's website, and I think they came up with something that and I see Libby was going to also speak about this. You're
Libby, you're muted.
Muted.
Well, I think that's a great question. The only question I wanted to have you guys respond to was the term carbon sink. Can you define that for us?
Well, it's basically where you can store carbon, and we can measure how much carbon can be stored during a period of time within a volume of soil.
Okay.
So if you disturb that sink and you till it and you expose it to the moisture and the air and the water, that carbon is going to diminish. And certainly we've learned that the carbon in the planet now, with this fugitive carbon, it's in the sky, it's in our atmosphere, and it's in our products, it's in our plastics, it's in our clothes, it's in all of our materials. And it's not necessarily where we would like it to be. We would like it to be in the soil.
So we have unwittingly become carbon sinks, right, Paul?
Exactly, but it's static too. It's not really helping any of the,
Doing anything.
yeah. Yeah, there's a good article my friend Bill McDonough wrote in Nature magazine, and the cover is the Vancouver Convention Center. And Bill has a real excellent and wonderful way of describing the world of carbon. And he's brought to mind some of these new terms around fugitive carbon and where it belongs and how we've changed the carbon cycle. And it's in our plastics, packaging, materials, and how we can change that paradigm with the reinvention of new materials. Also with the understanding that we can take those biological nutrients and keep recycling them. That's the circular economy. And then we can take those technological agents and keep those separate too, so that we're not commingling them. That's going to help that carbon cycle. And it's a good conversation to have given the climate change summit that's about to occur. And it, we think about this, that every one of us in our own way affect this conversation with the choices we make daily. And I think that's the call to action here, is that as architects and planners, designers and engineers, we have so much effect locally and otherwise on all these elements around carbon and carbon sequestration and impact to environment. And I just hope we all get to a point where we're making it better and we can do more good.
Yeah. Catherine Rhodes has asked a question, and it's got a word in here that I'm probably going to butcher the pronunciation of. Have you done any testing in regards to mycorrhizae network?
Yeah, mycorrhizal is that microbial community in the soil has an interrelationship with plants and roots and trees, and it's really a fascinating topic around mycorrhizal networks and how it creates a electrical chemical communication chain within the soil. It also enhances water and water infiltration and the way water and nutrients are cycled. With mycorrhizal fungi, phosphorus is then processed and locked rather than lost. So yeah, we do a lot of work in regard to mycorrhizal fungi, and we enhance those sites because you can apply it. There are commercial sources and various formulations. It certainly supports and enhances a long-term performance of plant life and soil health, and all that research is certainly available. We use it at our nursery so that we don't have to use as many fertilizers, and also it enhances the health of the plants, so we're not chemically dependent on pesticides. So I'm glad that we don't have really the time to get in deep around mycorrhizal fungi, but it's a good question.
Okay. And I want to say something. Charmaine let me know that some folks are working on an older version of Zoom, and therefore she's not able to unmute you. So if you have a question and that's the case and you can't get unmuted, feel free to type it in the Q&A box. Mm-hmm. Heather Johnston has a question, and it sounds rather project specific, but they're working on restoring a foothill grassland with some oak woodland at the perimeter, and it's infested with weeds and a mixture of natives. And she's concerned about losing the existing weeds. And so wondering if hand pulling those weeds is better, or you'd have less soil disturbance using selective herbicides. And I imagine this is a project by project response to that question, but is there sort of general information that you could give on that, or really does it depend on what you're seeing out in that particular field?
There's an organization, the California Native Grassland Society, that I was a founder of some 25 years ago. And there are an abundance of papers on restoring old fields in California. And I'm glad there's some sensitivity to the natives that are already there, because that means there's a seed bank. But, you know, with the advent of the clipper ships and the settlement and the introduction of European livestock to California in the 16 and 1700s, our grassland ecology was forever and profoundly changed with plants from the Iberian Peninsula that are annuals. And they occupy the top 2 inches of the soil, and they grow fast. So these perennial natives and some of the diminutive wildflowers don't have a chance. And we've really lost a great deal of biodiversity and soil health because of it. But the hand pulling is a great way to go about this, but focus on small areas. And then biannual mowing is effective. You can tip the balance by absolutely getting those weeds. They're annuals, so they have a short life cycle. Their seeds don't last long in the seed bank, so just control their ability to go to seed. And if you can mow the tops off before the seed is mature, definitely don't do it after the seeds are mature, because then you're spreading the seeds. Then you could plug in various natives into that matrix in the fall before the rains. You can tip the balance to a more weed-free perennial grassland by doing it that way, rather than herbicides, because with herbicides you're going to kill off the mycorrhizal and the nutrients as well as the biota in the soil. And with disking you do the same thing, and then if you disc you can disturb the existing natives. So that's a good question.
And then Marilyn Crenshaw is asking, can sewage be filtered to gray water to then used for irrigation? Are there proprietary products and equipment that local jurisdictions would approve? And I mean, this is always that, you know, that dance between the regulatory agencies and what we can do as architects and designers and what they're going to let us do in terms of permitting and allowability and things like that. So,
well, sewage is not gray water. That's the first point of clarification. That's black water. That's should be that's a second tier treatment. Now, I have used in Mexico on big projects, we've actually used composting media to filter sewage water, not the solids, but the water, and treat that and polish it to a point where we reused it in the landscape. So that was actually black water. In here, you have to run that through a biodigester or a biofiltration. And you could do this with gray water. People are doing it all the time, which is, you know, your lavatory water, your shower, or your laundry, but certainly not with your sewage water. And that requires specialized treatment equipment and treatment train.
So that conversion of black water to gray water is the tricky one.
That's the one that requires more regulatory oversight from the health and safety. Mm-hmm. We did a gray water first commercial gray water project at Fort Ord, where we took 240 homes and took their shower and lavatory water and ran that through a gray water system and storage, and then and only 27 of those homes contributed, but we used that for the irrigation water and got to a zero potable water for the rest of the site. So that's the gray water is the way to go. I mean, if you want to conserve water, for sure.
And you said you got it to potable water. Did I hear that correctly?
No, at no time would we convert it to potable. No.
Okay.
These are for secondary uses, landscapes, or irrigation kind of applications.
Gotcha.
Same
And then that
thing
situation.
on the Transbay terminal, we did this as well using laboratory water. So the reuse of water is there. Many of my projects are quite old, and now the technology and the equipment is plug and play, and even for commercial applications, offices and buildings that are going for living building challenge or really have a shortage of water.
Okay.
Pebble Beach companies setting in that system for their golf course irrigation.
Mm-hmm.
Since they have a control of the community. And because of that, I've learned that other golf courses in other communities that I'm not involved with are actually thinking about it the same way, because they know that the population is usually pretty pro golf course in some ways. And that's a way to distribute this gray water.
There are problems with reclaimed water. Oftentimes the ECs, that's the sodium level, are high.
Yeah.
So it affects the pH. And when you affect the pH in the soil, it loads. So you need a flushing cycle of potable water or rainwater in order to balance that pH. You can do it with nutrients, but oftentimes plant performance is challenged. So you can do it with nutrients and fertilizers and flushing, but those are other strategies.
Yeah.
So what was going on down there in Mexico, Paul? How did
that was for
regulatory oversight, or were they just letting?
No, there's no fear and loathing.
Yeah.
I mean, when you talk about waste here, everybody, ooh, smelly poo and pee. It's like there's this social cultural taboo, and yet in areas that I think this was 4-centimeter rainfall in Saltillo in the mountains for a big steel plant. They wanted a beautiful, lush landscape, and so we just took all the black water, separated the solids. That's from all the toilets and all the water from the labs and everything else, and then all of that liquid was then processed in a big mulch, kind of a layered media mulch pond with and a fountain. It was isolated, and then all that water was used in the landscape, a beautiful lush landscape for Diacero, and zero potable water.
Yeah.
And that's what was going on there. I love this question. I'm currently finalizing the design of using captured rainwater for toilets and washing machines. Yeah, the challenges are this. In the current plumbing code, when we did that four-door project, it's the health and safety regulations. You have to have a design review checklist, and it has to mean filtration, purification, a backup system in order to maintain that water is clean for anyone that's going to come in contact with it. So filtration, purification, treatment, you can use UV, you can use chlorinator, which I'm not big on, or you could do it through a biological filter. But those are Matthew, that was a great question. And answer this question live. Okay.
I actually had a question for you guys. As you know, the fires in 2020 in Santa Cruz and Monterey counties, how does this affect the soils, and what are some strategies in healing the scorched earth now that most of the sites have been cleared of hazardous materials and the sites are beginning to be planned or rebuilt? Do you guys have any projects in the burn areas, and how do you like to approach this?
Wood chips. I like to use wood chips and mulch, and that protects the soil. You know, the soil gets hydrophobic, and so it allows the native vegetation to come back, which it will, and then it protects the soil in the interim. And it doesn't have to happen everywhere, but any place that's been graded or cut or historically disturbed is pretty vulnerable.
Okay. Note that the last question I'm seeing that hasn't been answered, so would be from Polly, and asking about mosquitoes and smelly algae in a detention pond, and if there's a way of handling that.
Yeah, keep the water moving. Put in a fountain, put in different typologies, run the water over a spillway, get more oxygen. Leaving water in a bathtub doesn't really lend itself to healthy, clean water. You got to get it moving and oxygenated, and that would be the first start. And then seasonally dry it down if you can. Use it for irrigation.
Great. Thank you. Well, if there's any other questions, people want to jump in and ask. But if not, I really thank all of you for participating today, both the panelists and attendees. We'll make a PDF and we can send it out to those that have been on the call on this webinar, and that will also post this video on the AIAMB website under the COTE tab. So again, thank you for participating and all of your contributions. This has been a really great conversation.